today we'll be learning about osmosis, and this is brought to you by STEMpower, and I'm assuming you guys are all in 5th or 6th grade. So to start, a little bit about STEMpower is we are high school volunteers, and we're part of STEMpower, right? An organization that hosts hands-on workshops for students like you guys to be, ideally we want to inspire an interest for STEM. So please, you can take note of the website, which is stempowerus.org. Our Instagram is stempower.us, and our YouTube channel can be accessed by tinyurl.com/stempoweryoutube. So if you guys or your parents have an Instagram, we highly suggest you follow our Instagram. We have very fun and informational posts and reminders for these meetings. So we highly suggest, and our username is stempower.us. If you or your parents have YouTube, we also highly suggest you guys subscribe to this channel. So if you're ever bored at home, we host monthly at-home activities that are fun experiments, and obviously they can be done at home. And also, if you happen to miss a workshop, we'll be posting all of these on the YouTube channel. Awesome. So to get started, let's have an icebreaker. So we'll all go around sharing our name, our grade, our favorite subject, our favorite ice cream flavor, and a fun fact about ourselves. So I'll start. My name is Oscar Tulich. I am in 10th grade, or I'm a sophomore in high school. My favorite subject is probably science, or specifically chemistry. I'm taking it this year. My favorite ice cream flavor is probably mint chocolate chip. And a fun fact about me is that I love sailing. So we can go in the order that I see you guys. Alright, so Nikhil, would you like to share?
Okay. My name is Nikhil Venugopal. I'm in 5th grade. My favorite subject is science. My favorite ice cream flavor is cookies and cream, and a fun fact is that I have a sister.
Awesome. Thank you so much for sharing. Would anyone else like to share first, or should I call some people? All right. Ethan, would you like to share?
Sure. My name is Ethan, and I'm in 5th grade. My favorite subject is math. My favorite ice cream flavor is bubblegum. And fun fact is that I have a brother.
Awesome. And who else would like to share? Just your name, your grade, favorite subject, favorite ice cream flavor, and a fun fact.
Can I speak?
Yeah.
Okay, my name is Roshan. I go to 6th grade at Mission San Jose Elementary. My favorite subject is probably math. Favorite ice cream flavor is vanilla. And fun fact, I have a brother who's actually gonna help me out here.
Awesome. All right, and anyone who hasn't shared yet, please share.
I can go. My name's Aaron. I'm in 6th grade. My favorite subject is math. My favorite ice cream flavor is mint chocolate chip. And a fun fact is I like cooking.
Awesome. Thank you so much for sharing. And then I think one more person hasn't shared, so please, Inbar, could you please?
My name is Inbar. I'm in 5th grade. My favorite subject is probably science. And my favorite ice cream flavor is chocolate, and the fun fact is I have 2 sisters.
Awesome. Okay. So let's move on to the lesson. So today we'll be learning about osmosis. And really quickly, I just want to share before we kind of get into the lesson, we will be doing an experiment today related to the lesson. And so I have actually done it already. So I want to give you guys a quick preview of what we will be doing today. So I have an egg, but it is very soft and it is very squishy and it looks weird and it smells weird. So it's a very fun experiment. So just like a quick preview of what we will be learning. Awesome. Now I need to share my screen again. Okay, let's continue on with the lesson. So today we'll be learning about osmosis, as I've said, but to get started, what is a concentrated solution? So a concentrated solution, for example, orange juice, is something that has a lot of stuff in it in comparison to something that is going to be dissolved in. So a concentrated solution is like orange juice, which is more concentrated with sugar than water, right? If you have a cup of orange juice and a cup of water, orange juice will be much, much, much sweeter because of all the water it has. Can anyone think of another example of a concentrated solution? I can start. If you have a cup of salt, a cup of salty water, it is going to be much more concentrated with salt than regular water. All right, if we don't have any example, that's perfectly fine. We'll just continue with some more vocabulary. Did someone say they have an example?
Yeah.
Sure, would you like to share?
Yeah, I think soap and vinegar.
Soap and water?
Yeah.
Yeah, that's a great example. The soap will be, like soapy water will have a higher concentration of soap than regular water. So great example. Thank you so much for sharing. Some more. Oh, did someone have a question?
I have a concentrated solution. Lemon juice has more citric acid than like water.
Yeah, exactly. Thank you. So that's a very good example. All right, and to continue with some more vocabulary, in a diffusion, the solute is the particles, so citric acid, sugar, soap. The solvent is the liquid, which is usually water, as we've talked about, and the solution is the solute and the solvent combined. So in our example, sugar is the solute and water is the solvent, and when you add them, you get a sugar-water solution. So we'll just continue familiarizing ourselves with those terms, and then it'll get a little easier. And then the last bit of vocabulary is diffusion. So diffusion is actually when the solute moves from an area of high concentration to low concentration. And so an example of this, here I can annotate, is sugar from the orange juice diffusing into the water. So here we have a high concentration of orange juice sugar particles, and this is high concentration, and the rest of the water is low concentration. So in diffusion, they mix and they create like a unanimous singular solution. So again, diffusion is going from high to low concentration.
Okay, I'm going to interrupt. Sorry. So there's actually an uneven amount of groups in one of the breakout rooms, so I will be moving someone from this room to another room. So this is just a little warning.
All right. Okay. All right, I think we'll continue now. Sorry about that. Okay. So kind of to sum up, diffusion is when you have a high concentration and a low concentration, and the solute goes from the high concentration to the low concentration in efforts to balance everything out. And again, in our example, we have a high concentration of orange juice concentrate, and it moves to the low concentrated of water. So is everyone clear on what diffusion is? Awesome. If you have a question, just feel free to unmute yourself. All right, and now we'll be applying it to what osmosis is. So as we know, diffusion is it's when the solute moves, when the particles move and diffuse through the water. So more examples of diffusion are food coloring diffusing into water. As you can see on the right here, we know on the left, we know that
I have a
there's
question.
Oh, go for it, Inmar.
Once I saw this cool video that someone he put ice and then with with food coloring, and then he put it in the water, and all the food coloring and the water mixes together.
So was the food coloring in the ice or in the water?
It was in the ice, but then it mixed into the water.
Yeah, that's a really good example of diffusion, right? There's a high concentration of dye in the ice or in the water, and then it mixes into the low concentration water, because as we know, regular water doesn't have any dye. So the solute diffuses. Yeah, that's a great example. And then another example of diffusion, which again is when the particles move from high to low concentration, is tea leaves. So if any of you guys have ever had tea, here I can do a little drawing to make it a little easier to understand. Does someone have a question?
I drink tea.
Oh, yeah, that's awesome. I drink a lot of tea too. So if we have a glass of regular hot water, and then we have a tea bag in it, the tea bag has a high concentration of like tea leaves, right? The particles. And as we know, regular water doesn't have any. So the water would be low concentration, and then the tea bag would have high concentration. So in diffusion, the tea leaves or the tea particles exit the bag and even everything out. And that's how we have like a new substance. We don't have a bag in water anymore, we have tea. So that's an example of diffusion. So now we know we have a pretty good understanding of what diffusion is, but what is osmosis? So osmosis is the diffusion of water. So instead of the solute or the dye or the tea bags moving into the water, this time the water is what's moving, right? So osmosis can be defined as the diffusion of water. It is when the solvent or the liquid passes through a filter from a region of high to low concentration. So let me do like a quick drawing. As you can see in this diagram, we have a beaker and it's split in half, right? Here we have, in this left corner, we have a high concentration of water, right? There's a lot of water and there's less particles. And in the right, we have a low concentration of water. There's a lot of particles and only a little bit of water. So in osmosis, the water is going to travel from high to low concentration. So instead of the particles moving as we've seen in the past, now the water moves, right? So there's actually the same amount of, there's the same amount of particles here on the left side and here, but the water is what's moving in osmosis to balance it out, because as we can see here on the right side, there's the same amount of concentration on both sides. But as before, they have different. This one's more concentrated and this one's less concentrated with water. And then through osmosis, they have the same concentration. So I know that can be a little confusing. So does anyone have like a question that I can help kind of clear up what osmosis is? All right, should I move on? So if I were to ask you guys what osmosis is, would you know what to tell me? Yeah? Okay, awesome. So let's move on. So what is the difference between osmosis and diffusion? So again, in osmosis, the solvent or the liquid or water moves. In osmosis, there's usually a filter that prevents the solutes or particles from moving, as we have seen in the past slide, right? There's a filter that prevents those little purple circles to move. And in osmosis, the water is what's moving, or the solvent. And then in diffusion, the solute, which can be orange juice, concentrate, sugar, salt, etc., moves. So again, I know I've repeated this many times. In osmosis, the water moves from high to low concentration, or the solvent moves. In diffusion, the solute, or the sugar, moves from high to low concentration. Awesome. So I think we have a pretty clear understanding of that. So if you remember, some examples of diffusion were like food dye diffusing into the water, or tea diffusing into the water, but let's look at some examples of osmosis, or when the solvent moves, when the water moves. So some examples of this will be curing a sore throat, watering plants, feeling thirsty, and then even wrinkly fingers. Okay. So has anyone here ever had a sore throat before? And if so, why did you get it? Do you know? And what did you do to make it feel better? All right. Nika, would you like to share?
I got sore throat because I had strep throat, and then I ate this like lozenge thing, and it said in the ingredients it was like water. Like,
that's really cool. I've actually never heard of that before. That's awesome. And then, did someone else have a suggestion?
Me.
Yeah, would you like to share, Imbar?
So once I had a sore throat because I didn't drink much, and then I drank a lot more. I got way better.
Yeah, you didn't drink enough water. That's actually a different type of sore throat, so that's tend to be because you're dehydrated, but a specific sore throat is, it's kind of is caused for a different reason. So a sore throat, like the condition, I guess is what you can call it, actually occurs because your throat and the tissues and cells in your throat become swollen with extra water. And because they increase in size and water, it can cause it to swell, and therefore can have a little discomfort. I know when I had a sore throat, what I do to make it feel better is I actually gargle salt water, which is what's on the next slide. So if any of you guys have heard of gargling salt water when you have a sore throat, it actually helps. It helps cure it. It helps solve the pain and the discomfort. So I wanted to ask you guys, why do you think, how does this make sense? Why does gargling salt water help a sore throat, which, as we recall, is when the tissues and cells in your throat have a high concentration of water? So, we have any brave volunteers that are willing to try to take a guess and explain why gargling salt water can help? And if we do have a volunteer, they can use the terms high concentration and low concentration to answer the question. So why does gargling salt water help the sore throat? Does anyone have a wild guess? All right, if no one wants to take a guess, I'll share. So as we discussed, your sore throat has a high concentration of water because it's swollen. That's what a sore throat is. And when you gargle salt water has a lower concentration of water than pure water that's in your throat. So when you're gargling salt water in your throat, the water moves from the high to low concentration, essentially through osmosis. The water that is swelling in your throat moves into the salty water, which then you spit out into the sink. So therefore, by gargling salt water, you get rid of some of that water in your throat, which helps the discomfort and basically cures your sore throat. Awesome. So the next example is watering plants. So if any of you have ever had a plant before, you know that when watering it, you water near the soil and near the roots of the plant. And why is this? Do you guys have any guesses, any ideas of why we water towards the roots of the plants and not the leaves? Yes, Nika, I see you raised your hand.
it's like the roots they can take in the water, and then I think there's this thing, we did an experiment at my after school where we put water and then there was tissues and we put food coloring, and the food coloring moved from the glass, and I think it was I forgot what it was called, except I think it's the same principle with the plants.
Mm-hmm. Yeah, exactly. So that is another property of water, but it's a similar idea. So basically, when you water plants, you water near the soil because it's an example of osmosis, right? So the roots act as the filter, and then the water molecules naturally travel from the soil, which is a high concentration of water, into the roots, which have a low concentration of water. So the water, the solvent, naturally passes from the soil into the roots, and then from the roots into the rest of the plant, right? And this is an example of osmosis. And also the roots act as a filter, so no small particles enter the plants, which is why it isn't diffusion, and instead it's osmosis, because as we know, the water is what's moving. All right, a next example of osmosis is feeling thirsty. So what typically happens to you after you eat something really salty like chips or French fries? And what do you think causes this reaction? So does anyone want to share what happens to you after you usually eat something really salty like potato chips? Nikhil?
My lips hurt a lot because salt dries it up.
Yeah, exactly. So usually after you eat something really, really salty, your lips or your throat or your whole mouth can kind of hurt, right? This is because once you eat it, that salt is kind of spread out to those cells. And so the cells, they're very concentrated with salt. And so then our cells, they become absorbed with water because to kind of balance it out, if that makes sense. So the cells have a higher concentration after that, if that makes sense. So since the water is being absorbed into our cells to balance it out, because after the salt, that's kind of why you feel thirsty, if that makes sense. All right, and then the next example is finger wrinkles. So what happens to you guys after, to your fingers and your toes after a long swim or shower? The picture has a hint.
Your fingers wrinkle.
What was that, Inbar?
Your fingers wrinkle.
Yeah, exactly. So after you take a long swim in a shower, if you go swimming for a while or you take a shower for a long time, your fingers become wrinkled. And this can be related back to osmosis. When you're sitting in pure water for a long time, the moisture from your fingers moves to the high to low concentration, right? Which is osmosis. So the water kind of goes into your fingers, if that makes sense. All right, so I know we've learned a lot. We've learned about osmosis, diffusion, the different examples. So I want to take a quick 10-minute break. I highly encourage you guys to get a water or get a snack, go to the bathroom. All right, so I'm going to be setting a 10-minute timer now. And you guys can either turn off or keep on your cameras. And I will also be playing a video in the meantime. So you guys have 10 minutes. Here, we'll be watching this video. About 5 minutes left. Can you guys hear me? Did you hear the video? Because I tried turning on computer audio, but I'm not sure if it worked. Did you guys hear the video? Oh, okay, awesome. So before we move on to the experiment, I just really want to make sure that you guys have a really clear understanding of what osmosis is, because I know my examples may have not been the clearest. So really quickly, I'm gonna just go over them. So when you drink, I hope you guys just bear with me for a second. So when you eat really salty things, you crave water because your cells in your throat and stuff, they have a lower concentration of water because of all the salt. And then you're really thirsty, right? Because your cells, they want that extra water to be equal. And then your fingers turn like wrinkly after you take after you're in water for a long time, because your cells actually absorb that water, which goes from a high to low concentration. The water does, which kind of that swelling can just kind of make it appear like pruny, as people say. Okay, so, and remember that osmosis is the diffusion of water from a high to low concentration, and it's when the water itself moves. Okay, so just like a quick review of what osmosis is. So now we're going to be doing an experiment, which is in my opinion the fun part. That I've already done. Sorry. So the first part is, can you guys name the parts of an egg? So alright, Nikhil, would you like to share?
The shell, the yolk, and the white.
Yeah, awesome. You pretty much got it. So an egg has an egg white, a yolk, a shell, and it also has a shell membrane. So we're all familiar with the yolk and the egg white, and then the shell. There's something that actually separates the egg whites from the shell, which is the shell membrane. It's kind of like a filter, and it actually protects the egg. It protects things like from bacteria entering the egg and from moisture leaving the egg, because technically an egg hosts a baby chicken, right? That's where it kind of, that's where chickens come out from. So that shell membrane is meant to kind of protect it from bacteria and anything from entering the shell. But then the shell is like the physical barrier. So please try remembering these different parts, because they'll be helpful in the next activity. So our objective is students will learn about how osmosis occurs in an egg. They will conduct an experiment on an egg to experience this process firsthand. So I'm pretty sure you guys should have these materials. So please have with you a raw egg, vinegar, or also I saw you, Nico, vinegar, a glass or plastic jar or cup, and food coloring. So everyone, you can take like a minute or so to get these materials out. They'll be on the screen for you. So does everyone have these materials? If you don't, can you please unmute yourself and share what you don't have? Awesome, Nikhil, I see. Alright, can you raise your hand if you don't have the materials? Alright, then I'm going to assume we all have them, so if you don't have them, speak up whenever you can. Alright, so we'll be moving on with the experiment. So our first step is to fill the jar or cup with vinegar. There should be enough vinegar to cover the egg. So in my jar, the vinegar would go to about here. Aparna, do you have a question?
I don't have all the ingredients or something.
What is there that you don't have? What are you missing?
I didn't know that we were going to be doing an experiment.
Oh, okay. So I think they're just like
Mom's going to be bringing the things that I'm going to need. So can we wait a little bit?
Okay. I think we have to stop at exactly 12 o'clock, so we only have 20 minutes. I think what we can do is this recording will actually be posted to YouTube. So if you want, you can just watch, learn the steps, right? See any and just learn from them, and then you can watch this recording and then do it afterwards, because we do have to get out of here at a specific time. Otherwise, we would wait. So, yeah. yeah, so you can just watch this because I'm not doing the experiment. I've already done it, and then we'll send out this video to you after. Okay. So take like a few more seconds to fill the jar with vinegar to make sure that the egg is covered. Ethan, have you covered your egg with vinegar? Have you got your ingredients? Awesome. And then the next step is, which is optional, if you want, you can put food coloring in the vinegar, but that's again very optional. All right, has everyone finished pouring the vinegar in their jar? Can you get a thumbs up, or if you haven't, speak up now. There. Is anyone using food coloring? Yes or no? All right, Nikhil. So, awesome. So if you put in food coloring, just let it sit for about a minute or so before you put the egg in. So let's take a minute. Right now we're just pouring our jars with vinegar, and if we have food coloring, we're going to let the food coloring sit for 1 minute. Okay, so it looks like most of us are done with that step. So the next step is to place the raw egg into the jar that's filled with vinegar. And the egg should be fully submerged. So take a second, carefully put your egg into the jar. Make sure it's fully covered with vinegar. All right, has everyone placed the egg? All right, Inbar, it looks like you're still working. Do you need help on anything?
No, I got it.
All right, awesome.
It's done.
So the last step is to leave the egg sit in the vinegar for 24 hours. This is what I've done. And then after 24 hours, you will get a funny looking egg that looks like the one on the slide. So, and then after class, so in exactly 1 day from now, carefully take out the egg from the vinegar, and you can wash it until it's completely clean. Yeah, and then the step 5 is to check in on your egg and make note of any observations that we can check in on next week. Okay, and so in the day, after you make your observations and after you wash your egg, as I've already shown you guys, your egg will look like this. Mine is yellow because I used apple cider vinegar because I didn't have regular vinegar. It's very squishy. It's also very smelly. It smells like vinegar. Yeah, so make sure that in a day, once your egg, after the experiment, make sure you don't break it because that would be very funny. It'd be very weird. My hands are very dirty now. Alright, so make sure you can close your jar container and put it somewhere where no one will touch it so they don't mistake it. Okay. Has everyone gotten their eggs? Gotten the experiment? And Aparna, did you get the materials?
Yeah, I got it on time.
Awesome, that's perfect. And so just a quick reminder, in exactly 24 hours, take out the egg, you can rinse it, and then also make note of any observations that occurred. So now, while we're waiting for those 24 hours, we're gonna have some discussion questions. So here is my egg, as I've showed. So what can you observe about the egg, and how has the egg changed from its original state? So how does my egg look different than your guys's right now?
The shell is different.
The shell what?
The shell is different. Looks yellow.
The shell looks yellow?
Or maybe the shell. I don't know. Maybe.
I'm not really understanding what you said, but if this is where you're going, the shell has, like the outer eggshell has mostly disappeared, and I peeled it off, but this part is actually still here, so it's still intact. So yeah, it's changed from its original state. There's no longer a shell, it kind of disappeared, but it seems as if the egg membrane is still there. There's something keeping it together. It's not just, it's not liquid. So, and then what else? What about the color? What about the texture? What about the shape? Nikhil, would you like to share?
Seems more bouncy and squishy.
Yeah, exactly. It's actually very bouncy. I don't want to drop it, but it's very bouncy. It's actually a lot bigger, and it's very squishy. And it's also yellow, which is weird. I don't think your guys's will be yellow, but yeah. So yeah, that's pretty much it. And what you also may notice during your experiment is that bubbles may start coming out of the shell, which is what I noticed. So some questions I have for you is, where did the shell go? And why were there bubbles coming from the shell? Is it Nikhil? Would you like to share? Do you have any guesses to these questions?
Yeah, I think the vinegar dissolved the shell.
Exactly, that is exactly what happened. So there's actually a chemical reaction between the eggshell and the vinegar, which causes it to disintegrate or dissolve. And also there's another chemical reaction. During that chemical reaction from the vinegar and the eggshell, it actually releases carbon dioxide, which is like those little bubbles that you may see right now as your egg is sitting in the vinegar. So I have another question for you guys. So why did the egg increase in size? Because as you can see, my egg is very large. So try to remember the parts of an egg. Can someone please propose a guess? And here's a hint. How does it relate to osmosis? Nikhil, would you like to share?
Like the shell, it's like the filter part, and the vinegar goes in through the shell inside the egg.
Exactly.
That makes it.
That is exactly it. So basically what happened is that vinegar has a higher concentration of water than the egg inside. And because of that special egg membrane, the water in the vinegar traveled from high to low concentration. So the water from the vinegar actually traveled inside of the egg, right? And because of its special membrane in osmosis, nothing left the egg, right? So the egg simply gained in size because water entered from the vinegar to the egg. All right. Okay, so that's pretty much it. That's all we have today. So I really hope you guys have a clear understanding of what osmosis is, and I hope you guys are having fun during this experiment. So in 24 hours, remember to check up on the egg, right? So the last step before I will let you guys go is, I cannot see, 1 second. You guys have to fill out a quick little reflection form. So quickly, so STEMpower knows like if you understood everything. I will now be pasting a link in the chat. So can you guys take a second to fill out this form? So again, at last, thank you guys so much for coming. If you're still doing the feedback form, that's great. We highly suggest that you guys check out our website, our Instagram, and our YouTube to stay updated. And the YouTube is great, so I highly suggest you guys check that out, if anything. And if you guys have any questions, there's more contact info on our website. So yeah, if you guys have any questions, you can raise your hand, but if not, you are free to go. And I hope you guys have a great weekend. Bye, see you next week.